Hi, my name is Mike Hensley. I'm with the Technical Support Group of Megger, located in Dallas, Texas. Today we're going to talk about the ODEN, High Current Injection Test Set. The ODEN was created in 1982 for ASEA, manufactured for them by Programma, located in Täby, Sweden. The current version of the ODEN, as we see it now, was developed in 1996. So now we're going to take a look at the construction as it exists on current deliverable products. Now we're going to look at the ODEN construction. As you saw on the video, I wheeled in the ODEN on its two transport wheels. So you can tip the ODEN back easily for transport. And then you can put it in its stopping position, then roll it down on its four hard wheels for actual operation. It's very well constructed that way. And what we've got is we've got a basic design that includes the ODEN controller on the top, which is what you're going to interface with on a manual operation. Then we have either 1, 2, or 3 current units stacked below that, and they're all resting on this two-wheel transport cart. Now let's take a look at the construction of the ODEN. The ODEN is delivered with a transport cart suitable for holding all of the parts on there. The transport cart has a collapsible platform which is held in place by a retaining pin right here. This is a pin that's on a spring release. Once it's in position, then that locks into place and keeps it from tipping forward when you load all the current units on there. So as you can see, that pin is keeping the platform from coming forward. Now first, before we load the amplifiers or the current units on here, let's lock the two front wheels into place so they don't go back on us when we try to load it. So now we have a good solid surface we can load the current units on. What I've done is I've loaded 2 of the current units on here onto the cart, and I've got the third resting in place, getting ready to place over top of the retaining ears. The cart is designed so that it has these retaining ears to hold on the current units and the controller as you load them onto the cart. Alright, so now we're ready to load the third current unit on. I'll place it on the retaining ears, and then I'll get the controller and put it in place. Now the controller's not so bad because it's only like 45 pounds. At this point we're ready to go ahead and plug in the units. What I'm going to do is I'm going to maintain my configuration as far as 1, 2, 3 or 1, 2, 3. However I want to name these, just in my own mind, all I want to know is all 3 current units are in the same configuration as they are there, stacked. So they're stacked 1, 2, 3 on top of each other, and I want to plug them in that same way. So let's go ahead and plug the first one in. Doesn't matter which one we choose. Lock that down. Get the second one. Lock that down. And the third one. And lock that in place. At this point we're ready to go. The only thing we need to do at that point is to hook up input power and output cables. Now let's look at the power input requirements of the ODEN. The ODEN has 3 different configurations. One is a 240 volt single phase input. Then we have a 400 volt single phase input and a 480 volt single phase input. Each connector is color coded. The black one is the 400 volt connectors. Then we have the blue connectors for the 240 volt, and the red is the 480 volt configuration. So what I have here is a 240 volt input ODEN. So we would take the large 3-phase ABB connector and plug it right in there. And it's very easy to plug it in, and we would connect the other end to our single-phase source. This is all powered up by 240, 400, or 480 single-phase. The ODEN can be delivered in 3 separate configurations as far as output current amplifiers or current units are concerned. We have the S version, which is the standard unit, and it has the 2 high current stabs available on each one of the current units. Then we have the H version, which is in the exact same configuration as the S with the high current stabs. It's just that it is the higher current version available in the ODEN family. And then thirdly, we have the X version current units, which is what we have right here. The X version is the same exact performance as the S, the standard unit, with the addition of the fact that it has an extra tap on the transformer output. So with these output taps here, you can get lower current but a higher voltage. So let's say, for instance, you're testing reclosers. A Cooper V4H recloser might take 120 volt compliance voltage to operate. In that case, you would need to operate out of these side tabs here, which are the X version adapters for low current, and then just select between 0 to 30 volts or 0 to 60 volts. When you add these up in series, you get the compliance voltage that you need. Now we'll take a look at the output cabling options for the ODEN. There's several different ways you can go about this. And if you look at the charts for performance, you need a certain cross-sectional area on the cables in order to achieve the amount of current that you need. Let's say you want to generate 5,000 amps as an instantaneous current. You might need the 120 millimeter cross-sectional area cable in order to get that much current through your test unit. Now that cable at 120 millimeters cross-sectional, that would be equivalent to a 4/0 cable in American wire gauge standards. As far as output cabling for the ODEN, there are several different cables that you can use. Just keep in mind that the more current you need, the more cable cross-sectional area that you'll need. Using the 120 millimeter cross-sectional area cable, which is equivalent to a 4/0 welding cable, that's what I've got here. Each one of these cables in the parallel bundle is a 4/0 welding cable. And we got 4 in this multi-cable bundle. You would have 2 of these attached, one on each side of the current output, one on the positive output stab and one on the return. What I've done is gone ahead and connected this one side so you can see how it's connected. We've looked at the construction of the ODEN, and we looked at the input power requirements and also the output cabling techniques. So I've got the ODEN connected now to a 20 amp wall source. As you can see on the wall, got it coming into the big cable, so we're not going to be able to trip a tremendous size breaker, but I do have a breaker connected. In this particular case, I have a Cutler Hammer 150 amp multi-case circuit breaker. It's in the open position right now, so I'll go ahead and reset the breaker. And I'm also, as you can see, connected to the high current stabs, the 2 center stabs. So it doesn't really matter what position my 0 to 30 volt, 0 to 60 volt setting is on, because that only controls the side stabs here. And since I'm on the high current stabs, it doesn't matter where that position is located. Now that we have everything connected, let's do a quick setup of the front panel just to make sure that we can trip this breaker where we need it to trip. I'll turn the unit on. We'll see that all the lights come up. Well, we want to go in a clockwise fashion to set up the ODEN. Make sure that our main switch, the F2 breaker, is off for right now because we don't want to accidentally trip the breaker while we're setting it up. We want to make sure that the hold light is lit so that we hold any readings when we're injecting current. Next, we move to the current adjustment section. I want to turn on the I/30 lamp because that's the way I want to get to the right point in the breaker current settings before I heat up any thermal trip elements inside. I want to make sure that my fine adjustment is somewhere in the middle of the dial. I don't want it to be in the noise level by operating down at 0 or up at the 100 level. And these are percentages. They're not actually current values. So I'll be somewhere in the middle. And I know for this breaker, a 150 amp breaker, I need to be somewhere up around 3 or 4 perhaps on the fine or the coarse adjustment. So I have my current adjustment settings where I want them to be for an initial injection. Next, I move over to the current ammeter and voltmeter inputs. I'm not having any external meter functions coming in, so these two are blank for right now, so it doesn't really matter what I have set there. Next, the output section. In this particular case, I have one current unit, so the default values that come up for high current and parallel are fine. If I had more than one current unit, I'd want to make sure that I was either on the high current outputs or the 0 to 30 volt, 60 volt outputs. In this case, I'm on the high current, so I'll leave it on the high current stabs. Also, I'll want to check and see if I'm in series or parallel connection. When there's only one current unit connected, it doesn't matter which position you have this in, so parallel and high I are both fine for this section right now. Keeping in the next section, I go to the stop input to check that. I have no auxiliary contacts coming in, so this light will not be lit. If there were some contacts coming in, this light would be lit to show that there's an input for the stop condition. In this particular case, I want to make sure that my INT light is lit because I'm sensing the internal interruption of current in order to use that value to stop the current injection. So I want INT lit. Next, we move over to the output section. In output, since I have the INT light lit, I'm using that as my stop input condition, so that's the light that I want. For instantaneous current injection, that's usually always how you're going to want it set up. If you're doing a long time or a short time trip, you may want the max time light lit. Alright, so we're at this point we're ready to do an injection, and remember I have my I over 30 enabled. So when I do a momentary injection at this point, I will see what current should be generated divided by 30. So that when I take off the I over 30, I'll be getting this first value before the divide by 30 sign. So let's do a momentary injection, momentary on. Well, that tells me right there that one of two things happen. Either I don't have my breaker reset, or my F2 mains breaker is not on. And I see that my F2 mains breaker hasn't been turned on yet. So I want to turn that on, reset the display, and try that again. Momentary on. I see I've only got 38 amps out there, so let me check the output breaker to make sure I've reset the breaker. Okay, I've reset the breaker so it's in a closed position. I'll reset the ODEN. I'm still on I over 30. Do a momentary injection. It looks like I'm going to have around 1500 amps once I take off the I over 30 function. So that should be enough to actually trip the breaker. Let's go ahead and take off I over 30, reset the display, and do an injection. Injecting current, well, first let's look at the stop condition, INT, and stop input. Make sure those are still set. Now I'm ready to inject current. And I do that with the on plus time. When I push that button, it's going to show me the time and the current that was generated in order to make that breaker trip. And since I'm looking at the stop input condition as INT, it should turn off the operating light as soon as that breaker operates. So let's go ahead and inject current. On plus time injecting. And it did trip. It tripped in 26 milliseconds at 1.51 K amps. And you see that my operate light did go off because I was sensing the interruption of current. We have a successful test. That's a quick look at the ODEN functionality. We've looked at everything from the construction, how it sits on its two-wheel transport cart, how to assemble the current units and put the controller on the top. We've looked at the input requirements as far as cabling is concerned, looked at the output section where you hook all of the current units into the ODEN and actually how to hook up to a breaker. And we've gone over the front panel operation of how to actually trip and test a breaker. The only test we've done at this point is the instantaneous trip test, but the long time and the short time trip test are not much different, just a few subtle changes that you have to do on the front panel. And we haven't looked at the advanced features, but that's something that your local sales rep can talk to you about, or your applications engineer if you have further questions calling into Megger. Thank you very much for your time and attention.